Alright guys, today we're looking at a variation of greatest common factor. Now it's going to look very similar to you. It's going to look very much like splitting the middle term, which is good. So this really shouldn't be too terrible, hopefully. So first, a recap of common factors. What I want you to do is factor each of these, A, B, and C, by factoring out the greatest common factor. Pause and then come back. Okay, welcome back. Here, the GCF is 3, and we get x plus 2. Here it's 5, and we get x plus 3. And here it's 3x, and we get x plus 2. So now the question is, why the heck do those work that way? Well, the basic reason is that we can rewrite each of these as multiplication times the GCF, and then we're just kind of undoing that multiplication. That's really all we're doing. Oops, I noticed I forgot a 2x here. Man, almost made another mistake. Luckily I saved this one by the end of the video. So we can do 5 times 2x here, plus 5 times 3. And here we could do 3x times x, plus 3x times 2. And then all we're doing is we're undoing that multiplication. Okay? So, when it comes to common binomial factors, look at what we have here. We have x plus 7 times x minus x plus 7 times 12. If we wanted to undo that multiplication, we'd pull out the x plus 7 and write x and minus 12 in parentheses. See, it's almost like we're distributing the x plus 7, right? We're distributing the x plus 7 to the x and the x plus 7 to the 12. This is very, 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 very much like splitting the middle term. Okay, so like, let's just do a quick example problem of one of those. So let's say that we have, I don't know, 3x squared plus 7x plus 2. We were trying to factor that. We'd be looking for numbers that multiply to 6 and add to 7. Those are 6 and 1. Split the middle term. And then after we take out the GCFs of 3x and 1, what we're really doing is we're factoring out a common binomial factor. We just tend to go the other way about this, and I've usually written it as 3x plus 1 times x plus 2. That's how I've usually written it, because to me I think of it as like kind of reversing the distributive property. But you could also write it as x plus 2 times 3x plus 1, factoring out the common binomial. That's really the same thing that we're doing over here. We see an x plus 7 times an x and an x plus 7 times a 12, so we're rewriting it as x plus 7 times x minus 12. Okay, try the exact same thing for these next couple and make sure that after you factor out the common binomial factor, you make sure everything is factored completely. Okay, pause and then come back. Okay, so here we should have had, and again the order doesn't really matter here, x minus 2 times x squared minus 9, because they both have that x minus 2, so we can factor out that common binomial factor. Here, this is meant to be a trick question though. Look at what you have left. You have a difference of squares left in this parentheses that can be written as x minus 3 times x plus 3. You do need to do that. Okay, get used to the fact that even after you do some factoring, there might still be some factoring left for you to do at the end. This is a tricky one. You kind of have to assume that there's a 1 here in C. But if you assume that there's a 1 there, it's really not that big a deal. You get 3x minus 1 times 5x minus 8. So I wrote it in the other way that time. You could have written 5x minus 8 times 3x minus 1. Remember, it's multiplication, so it doesn't really matter. Here, I tricked you, maybe, possibly, I don't know, because I'm not there. You can't factor that, not as it is. Your only hope would be to, if you were really, really desperately trying to factor this, okay, now I really wouldn't have expected you to do this, it'd be to distribute and combine like terms and then try to factor, but as it turns out, you can't factor that either. There's not two numbers that multiply to 6 and add to -1, not positive 6 anyway. So this can't be factored. Okay, so this is prime. We can't because we've got an x plus 1 and x minus 1. Maybe I tricked you, maybe I didn't. That's it for this video. Really, this should have looked pretty familiar from splitting the middle term. The process is the exact same. This is really just meant to set up factoring by grouping, which is coming up in the next one. That's it for this one.